With a histogram, the distribution of data can be displayed quickly and clearly. In this lesson, we will cover the basics. And hello again to this lesson, which essentially has two learning objectives. At the end, you should know what a raw data list is and how the distribution of values can be made visible with the help of a simple tally. At the end, you should be able to create a histogram yourself. This lesson is divided into two chapters. In the first chapter, we talk about the data collection, data preparation, and the first visualization by a tally. In the second chapter, we then create the histogram belonging to this data. This for both relative and absolute frequencies. Let's start with the raw data list and the visualization of the value distribution using a tally sheet. As an example, we use the diameter of a piston. The piston shown here is the basis of our fictitious data collection for the measured actual values. The characteristic to be measured is the diameter of this piston. This has a nominal diameter of 60.1 mm. Its tolerances are minus 0.1 and plus 0.1 mm. Due to inaccuracies and disturbances in the manufacturing process, the actual values will vary around the nominal size. We will continue to carry the image of the piston with us on the left side, slightly reduced as a reminder. For the further considerations, we assume that a sample of 56 pistons was taken from a production lot. Their actual diameters were measured, and the actual values measured were recorded in a table. The pistons were measured in random order, and the measured actual values entered in this table. A note on this: the test specimens should always be numbered consecutively in order to have a connection between the specimen and the measured value. This can be an advantage if questions come up during the further evaluation. This table with the raw data of the measurements is the measurement protocol. We want to emphasize this again as the first learning objective. A raw data list is therefore the direct result of data collection. Any distribution of the values cannot be seen in this list, and even finding the smallest and largest value is rather tedious. Therefore, in the next step, the data will be sorted. The data is sorted by looking at the tolerance and the measured accuracy and forming appropriate intervals accordingly. Since the test characteristic has a tolerance of plus minus 0.1 mm, a measurement accuracy of 0.01 was selected here. Accordingly, the interval in our table is also 0.01 mm, starting at 60.03 and ending at 60.17. Such tables can sometimes be very long. That is why one likes to combine several characteristic values in groups or classes as shown here. This already reduces the length of the table to less than half. The class width describes which smallest and which largest value still belongs to a group. So, in the class highlighted here, a minimum value of 60.04 and a maximum value of 60.06 would still be part of that class. However, this type of representation also has the disadvantage that it results in a loss of information. For example, the process location can no longer be assigned to a single value, but only to a class. Therefore, we will not create classes here and continue with the original list. The tally sheet shows how often a characteristic value is represented. For each existing measured value, a line is then drawn for the corresponding characteristic. If, for example, the value 60.03, shown here in yellow, is only there once, only one dash is entered. If the second yellow value, 60.07, occurs 5 times, it gets 5 dashes, and so on. If this is carried out for all measured values, a distribution of the values becomes visible. Here we can see an accumulation around the value 60.1, and the spread ranges from the minimum value of 60.03 to the maximum value of 60.17. Here again, highlighted by the envelope in red. When we have just counted in the tally how often a value occurs, we have determined the absolute frequency. The term absolute frequency is therefore synonymous with the colloquial term number. The absolute frequency is therefore the result of a simple count. We will talk about the relative frequency, which is also very often used, in the next chapter. In this chapter, we create a histogram based on the data from the previous chapter. As already mentioned, the histogram is a graphical representation of a frequency distribution. This applies to both absolute and relative frequencies. Let's start creating this chart with the x-axis. This has the same measurement intervals and the same unit as our tally sheet and goes from 60.00 to 60.2 mm. The absolute frequencies of the measured characteristic are shown on the y-axis, starting at 0 and ending at 10. The relative frequencies, or frequency densities, would also have been possible, but for the sake of a better overview, we forego this additional axis for the time being. If the measured value 60.07 occurs 5 times, the blue bar has also a height of 5. So let's enter the missing bars in our diagram in the same way. In a suitable diagram, such as the histogram shown here, some characteristics of the distribution are immediately visible, as we will see in one of the next lessons. If you add the lower limit and the upper limit of the nominal size to the diagram, it is very easy to see that most of the values are right in the middle of the tolerance. So the process location is right in the middle. Do you remember? In a previous chapter, we discussed the terms accuracy and precision. In addition to the y-axis for the absolute frequency, another y-axis for the relative frequency has been added here. The relative frequency indicates how large the absolute frequency is as a proportion of the total number of values. For example, if the reading 60.1 mm occurs 8 times and the total number of readings is 56, the relative frequency is 8 divided by 56. The result is 0.143. In other words, 14.3% of all parts are 60.1 mm in diameter. The question often arises as to how many values are below a certain limit. The absolute and relative cumulative frequencies are here also useful representations. The cumulative frequency is calculated as the sum of the individual frequencies of the characteristics from the smallest expression to the limit value. The limit value can be found on the x-axis, and the number or proportion of values that are below this limit value can be read off the y-axis. Well, that was a lot of new information. Therefore, I would like to conclude by repeating the 3 most important key messages. The raw data list contains the raw data of a data collection. A tally shows the distribution of the raw data. Each dash is a measured value. A histogram is a graphical representation of a frequency distribution. The location and size of the frequencies can be easily seen. If you found this lesson helpful, please let me know and leave a comment. Thank you for that, take care, and see you next time. Bye.